Okay, in this video, I'm going to talk about designing custom components for NS3. Let me adjust the mic. Okay, designing custom components for NS3. First of all, let me show you the code that I have. And so I have here, I'm in the root NS3 directory. So I'm right here under this doc. This is where I run my WAF command. So that's what I am. I'm going to change into Scratch, and then I have custom application example. As you can see here, this is a project, and I call it custom application example, and I have in it a number of files. So wave project is the file with the main function, and the others are like customized components or helper classes. This helps you write neat code in your main method or main function, and then have other functionalities in other classes. And I'll talk about this from different perspectives, I guess. Basically, first let me run it. So to run it, I would do WAF run custom application example, and it will show you some output. So it's running. I'll show you the code. I'll go over the code now. Okay, so this is the wave project. This is the one with a main function. So it's called wave project. I put it here. I'm going to have 5 nodes, simulation time 4 minutes, define certain things. The basic components are creating of nodes. So I'm going to create however number of nodes I design here, or whatever I pass to it as a command line argument. Then I'm going to install mobility in these nodes, and I'm just going to have nodes with different position and velocity. So I'm going to use constant velocity mobility model, and the nodes will all be going in the same direction. If I do visualization of this, I have a shortcut to run visualization. It will show you nodes like this. So I have default 5, and then they will all go in the same direction with this lane going faster than this lane. Okay. So that's about position and velocity, right? So they have a starting position and a starting velocity, or a constant velocity, because the velocity doesn't change in this example. If you want velocity to change, you would use constant acceleration mobility model. Now, up till now, this should be easy to understand. We have nodes. The nodes have mobility, and that's it. We don't have any devices attached to these nodes. Now let's do that. So to do that, I basically designed a custom class called Wave Setup, and I basically just do configure device nodes and just one line. So Wave Setup is under, let me just list them as a list like this. As you can see, Wave Setup, I have a header file and a C++ file. So let's look at the header file. Basically, to design a class for NS3, I'll be using this in my code. And so I first have the include guards. This is just a common C++ practice. And then I will include the necessarily includes. So in this case, I just include the modules that will be used. And just put things inside a namespace NS3. This makes your life easier. And I'm just going to call this Wave Setup, the class, a constructor, a destructor, and this one function. Of course, we could design this to have more parameters, more items, more private variable, and get and set and all that, but I just want to keep it simple. The Wave Setup class, the constructor is empty, the destructor is empty. This is the function. Basically, I'm doing the same code I did from previous example, but I am returning a reference the object here, the net device container. This code, I described it before. You can customize this. I'm using the default parameters of Wi-Fi channel and wave physical and MAC layer. It uses OCB Wi-Fi MAC. You could customize this, but that's not the purpose of this lesson. Basically, I'm just creating it. setting up all the nodes with the proper radio devices, which is DSRC, which is WAVE, Wireless Access in Vehicular Environment, and then just getting that reference here. Let's go back here. And so that's it. Once we pass these two lines, you can see I have shorter code than having like a lot of that code that I have right here injected here. It will make my main function big. The next thing is to create applications in Node. Remember, nodes have devices and applications. And so the devices are created here and added inside that function. Creating the application can be done in multiple ways. I have my own custom application, and I just create an object of that custom application. I define this function, and I set some variable, and then set the start time and stop time, and then do nodes that get the ith node, and add an application. So I'll add one application to every node. So how do we design a custom application? We design a custom application as follows: a header file and a CC file. And as you can see, they are in the same directory here, CC and header. So first, the header file. Include guards, which is, good C++ practice to avoid multiple includes. Your class, if it's an application that starts and stops, has to be a subclass of application. It's a good practice to implement get type ID and get instance type ID. These are basically, this is the standard in ns3, and I'll go over this maybe later. This function is basically inherited from application, the code that gets executed once the application starts, and then user-defined function. I have a function called broadcast information, receive packet, promiscuous RX, set broadcast interval. So we've seen set broadcast interval. It basically sets a class variable here to that certain time. There is a packet size, and there is a WaveNetDevice. Basically, this is for convenience because an application has access to the node, and the node has access to the devices. And so you could actually access the devices and manipulate them, as I will show you in the function start application. The get type ID, the basic idea here is to create, the get type ID has to be a static function. You have to create a static type ID variable. So it's one class, one value or one variable that is used for all classes that use this class. This is a C++ or object-oriented programming. You have to know what static means. And basically, the key components here is set parent and add constructor. The code would work if we didn't have these two functions, but this is just for clarification, as I'll clarify something, which is the object factory and how it's used. Get instant ID is almost always the same. You have the class name and then get type ID. And so get instance type ID is a virtual function. Always, so because of polymorphism of C++. And the key component here, I believe, are the add constructor, which can be used for object factory and the set parent. But anyway, the default constructor basically has default values. The broadcast time is 100 milliseconds and the packet size is 1,000. I'm gonna have start application. Once the application starts, let's get a pointer to the node because applications have access to the node and nodes have access to the devices. We'll see here. We'll go from I equals 0 to I less than n number of devices. So because a node can have multiple devices, it has one. I know it has one, but I'm just going to go through the code for formality. And so I'm going to get device at I, check the instance type ID if it is WaveNet ID. As you can see, get device returns things of this abstract class net device. And so if you know your polymorphism in C++ or Java, that's basically what's going on here. This static type or compile type is device, but when we do get instance type ID, we're getting the runtime type. And in this case, when the program runs, because we installed WaveNet devices, it will have WaveNet device. So I'm just making sure that it equals to get type ID. Notice here class name colon colon get type ID, because get type ID is a static function. Once this check succeeds, I'm gonna downcast WaveNet, the device here, to WaveNet device, because I'm confident that I'm sure that it is of this type. I store it. So for this net device, I'm gonna set the receive callback, and we do this signature make callback, and I have a function called receive packet. What happens is every time that device receives a packet, we will call this function that we defined here, receive packet, in this class, and it will be invoked with certain parameters. Another thing we could do is we can actually, using that device object, get access to the physical layer implementation. So in this case, we have Wi-Fi fee. So get fee here it returns a vector of all the radio devices attached to the radio interfaces, or it's called a physical layer implementation, because it can have multiple ones, but by default in ns3 it has only one. So I'm just getting the first one. This gets a vector, and I'm just going to store it in Wi-Fi fee. So Wi-Fi fee implements the physical layer, propagation, loss signal of WaveNet device, because it's basically the same standard. It uses the same standard. This is not what I needed to look at. I'm going to look at here. And as you can see, I'm tracing, connecting to a trace source called monitor sniffer RX. Let me look at Wi-Fi fee, which is a huge class to comprehend. I'm just going to look at type ID, because I want to look at so colon get type ID, that trace source. So the trace source is called monitor sniffer RX. As you can see, there is a lot of things here, phi-tx, and so I'm going to look at monitor sniffer tx. I'm using monitor sniffer RX. As you can see in the code here, we're connecting to this trace source. I showed you earlier in another video that you can have a full path, and that works too, but you have to specify the node ID in that path. So this is a promiscuous callback, meaning even if the node is not directed to your MAC address, you would still capture it in this function and maybe do something with it. Let's say, for example, you want to know how many neighbors do you have in your, people around you, in the network. The important thing here is this signature. So we have to match this signature, packet, UNT, which is the channel frequency, Wi-Fi TX vector, MBDU info. So these are the type of the callback. And if I look at promisc RX, I could see that I actually do just that. It's a packet integer for the channel frequency, integer 16, TX, MPDU, and signal noise. Let me go back to start application, was it? Yeah. And so this is without context, therefore the first parameter is not the context string, as you might have seen in my previous video. So you don't need the context string here. And the reason why we don't need that is we're already using an object to call it, right? So we're using phi object. Anyway, so I can also do a check here if wave device. So if we actually manage to set this wave device. So if this check succeeded, I'm gonna maybe create a random value and then just generate a random time, and then broadcast time plus some random offset. This is just to avoid having all applications broadcasting at this exact same moment. So I just have some microsecond random, just to introduce some randomness. And at the end of this start application, I'm going to give a call to broadcast information function. So after this time have passed, I create a function called broadcast information, and I'm just going to invoke that function after this time. And what happened in broadcast information is every time I run this code and then schedule the next broadcast. So I periodically broadcast information, right? So what does this function do? It basically prepares transmission parameters, creates a packet, adds a tag, which I will talk about later, a little bit later, create a packet tag with some data, and then attach that to the packet. So packet add, packet tag, this tag, and then I will send the packet with as a broadcast to the broadcast address. This is the protocol number, which is WSMP protocol, and using these transmission parameters, so I could adjust these parameters. You have to do it on CCH. If you do it on another channel, you have to play with the net device to tune it to that channel. So I'm not going to go into that detail. And then basically we send the packet, right? And we send the packet, and then it will be received. It will be received here, but will also received here. Actually, this one is called first because this is a physical layer and this is an application layer. And if I have this uncommented, don't I? Yeah. And if we notice something, receive packet here is at an application layer, and promiscuous RX is at a physical layer. And so if I run it, what I do here is I'm printing the packet size. This function will get me a larger packet size because there is the MAC header and such information. So this call to promiscuous can be useful if you want to collect these information in your custom application class. Let me run this. I actually have a shortcut R, run the last application. And I do not think I have the promiscuous one running because I did not save this. So let's do that again. All right, as you can see here, the promiscuous, so let me just go to the last node, okay? So promiscuous was called at node 4. So node 4 received something. The channel frequency is this. The transmission mode was this, Wi-Fi mode. The signal strength is this much, and the noise is this much. The size is 1038. And I actually, what I do here is I look at the Wi-Fi MAC header of that packet. So the way you do it is basically you create an object this way and peek the header. So if this is successful, the values in the header here will be set. And so basically I'm getting the address of the destination, the source, and I'm just checking my MAC address. So maybe to decide if it's directed to my MAC address or if it was not directed to my MAC address, because this is promiscuous. It will pick up any packet, whether it's destined to your MAC address or not. And so I say here that it is from this MAC address, and it has the sequence number in the Ethernet frame or Wi-Fi Ethernet frame, Wi-Fi MAC frame is 38. In receive packet, I actually do not have the Wi-Fi MAC header information. I cannot do anything with it. So I'm saying here I received the packet from this address, which is a different format, and the size is 1000. This is exactly the size of payload we set the packet with. So if you look at the broadcast information here, you can see that the packet size is set to 1000. I set it to 1000. So we get exactly 1000, while the promiscuous function, which is on a physical layer level, receive some extra 38 byte, which is header information. Okay, so basically this is what this program does. It basically broadcasts some information every 100 millisecond, and whoever receives it will basically output some values, right? So you can manipulate this class. I'll make this code available online on my Git repository, so you could download it. let me go over broadcast information again. So this is a custom packet tag. Basically, it sets the node ID in the tag and then sets the position. So it uses the node object and then gets the position of the current node that has this application and sets it. So I have created set node ID and set node position in my custom tag. And this is the next thing I'm going to talk about. How to build your own custom tag. So there is an in ns3, you can add headers to the packets, but that can get messy because adding headers and removing headers changes the size of the packet. Adding while adding tags does not change the size of the packet, does not modify the packet, which is very good. So I'm going to go to create two classes here, custom tag.h, custom data tag.h, and custom data tag.c. And it's in the same directory as the others, right? So custom data tag cc, custom data tag.h. So we create a class that the same thing, we do the same thing, include guards, enclose it in a namespace ns3, and I'm going to basically inherit from a class called tag, which is an ns3, right, class. I'm going to implement get type ID, get instance type ID, and get serial. So all these functions here are inherited, right? I'm going to look at what this tag has. So it has 3 different instance variables. There is a vector which has x, y, and z coordinates of a position. I call it my current position. And then an integer representing 32-bit integer representing a node ID and a timestamp, which is of type time. So timestamp is stored as double, vector is stored as 3 double values, and node ID is stored as an integer, right? And so I could have accessor and mutator functions, which I am using here. So I'm setting node ID and set position ID. What about set timestamp? I actually set the timestamp inside the constructor. So if I go to the constructor here, I'm setting the timestamp to now, and the node ID, I just give it -1, meaning it's unset. But I can also have a different constructor that does that. So get type ID is the same thing. Most important thing is set parent, add constructor. I'm not sure if it's necessary here. I don't think we will need it, but it's good for good practice to have them. Oh, this is wrong. Okay, custom data tag. So the functions that are inherited get serialized size. I have to implement these functions with the same signature. So I'm gonna return the serialized size of this tag. So it has the size of vector, size of time, size of integer, because these are my 3 instance variable. Okay, that's very simple. So it should return. Here we have 3 doubles, so every double is 8, I believe. Is it 8 byte or 4 byte? It's 8 byte, so 24, whatever. So it gets a value here, but you're not gonna deal with this value anyway. Serialize is when you basically write things, something to a packet or to a tag, a packet tag. Packet tag, again, is just for simulation information passing around, right? So just so that you don't have to deal with the packet itself, like manipulate and change things in the packet. So I'm going to write the timestamp, so get double, and then basically this function, we use this same function signature, so we will use this buffer iterator, and basically I will write double my timestamp when it's a double value, and then I will write 3 doubles for the vector x, y, and z, and then I will write the node ID. There is a serialize and there is also deserialize. Deserialize should have the exact same order. So in deserialize, I am reading double from this what do you call this thing, from this tag, so from this iterator, and then reading 3 doubles, storing them in XYZ, same order as before, and then reading U32 and storing it there. So this is just pretty much a formality. Whatever you have, make sure you do the right function. If you look at the documentation for tag buffer, you'll see read double and other functions. Read 32, U32, I think there is U16 and U8 and all that. There is a print function that has this signature. This is also inherited. So for this function, I think this generates output with ASCII traces, but I haven't tested it yet. So basically it takes an output stream and then basically passes something, whatever you want, to that output stream. And this is your accessor and mutator. Get node, set node ID, get position, get timestamp, set timestamp, get and set functions. And so there you have it. This is how we create a custom application. So we created an application of our own type and then created a helper class, but basically just to set up the wireless devices. Another thing I want to allude to, I want to talk about. So we got here set parent and add constructor. So why is get type ID and get instant type ID used in ns3? So another way of doing this, let me comment this code and run. Oh, where did I go? And then create applications in a slightly different way. This is called the object factory method. And so I have an object factory, and then I could set the type ID to custom application get type ID. Therefore, we have the proper type ID, and then call the function create, and then create the application. And then I could set the start time, stop time, add application, and so on. There are different ways to call set type ID. So I could actually do it like this as custom type ID. Well, not custom, custom application. And actually, I can also do this like this if I want to. Why is this useful? We'll show you in a second. I'm going to run the last modified program, which is my program. And I will see that I get exactly the same output. So this can be useful because I can have basically pass the application type as a parameter. So I could have different custom application classes with different names, and I could just pass it to the same function and it will construct an application for me and put it in an application. One last thing, setting add attributes. So there is a function called add attributes. Like you could add an attribute here, add attribute, right? So let me just go to a code I have and show an example. So where was I? I have CACC and I have model and CICC application. I have a lot of code written. And so I'm going to go interval here. I'm just going to copy this one. I don't memorize how I do these things. So let me go to custom application now and add attribute like that. So I'm going to set an interval to 10 milliseconds, which is kind of stupid fast. And I'm going to have this custom application to access what's my broadcast time here. It's called broadcast time. And here, broadcast interval. Okay. So basically, add attribute adds an attribute called interval. And this is a description of that attribute. And this is its initial value. So I'm going to set its initial value to 100 milliseconds. And I'm going to use broadcast time here as accessor. So basically make time accessor. There is also make double accessor if the value is of type double. There is make u integer. There is a different make accessor and make checkers. So this is the right one for double for time value. I'm just showing it as an example. And the name is interval. Okay. So and we have a constructor here, which is always the default constructor. Now, forget about the default constructor. Since I have object factory method here, there is an advantage that I can say fact.set interval to time value, and let me say milliseconds, 10 milliseconds. So I just want to show a noticeable change. So before I even constructed an object, I can actually set attribute values. This is why getTypeID add attribute is useful. Let me show you. So how many packets did we have here? We have up to 38. So we probably will have something in the hundreds if we run it. And maybe there is some packet loss. So we'll see how this works. Please work and don't embarrass me. So I have add attribute. Oh, where did I went wrong? Custom. Oh, shoot. There is something here. Leftover code, it's called. All right. Let's clear this mess and let's do it again. So there is a lot of packets. You see it's like 300 and something, 10 times as many packet sequence numbers. All right, so this is a tutorial about, I'm done with this tutorial. It's about creating your multiple classes, putting your code into multiple files, creating an application, and using the getTypeID and object factory, and also creating a custom packet tag. That's all. Thank you very much and have a nice day. Thank you for watching. Subscribe to my channel. Send me a message or comment if you need any help. And I'll see you on the next one. Bye-bye.